Hi Nat5, so we are looking at nitrogen in ecosystems in the Life on Earth unit. So first of all, we need to just remind ourselves why we need to have cycles. Okay, cycles are there because everything we have on Earth is a finite amount, a set amount. You'll have some argument that you get a tiny bit of increase because of meteorites, but that's hardly going to be enough to increase if we used up things in the biosphere. So when we use things, what has to happen is they need to be cycled back in to another usable form. Okay, and that means that we also need to remove all the waste that's produced during our lifetimes and all the dead stuff at the end of it. Okay, so the things that do this most, bacteria and fungi. They are our decomposers that break things down and do the bulk of the recycling that we need to happen. Okay, there's actually more detail at the Nat4 in the nitrogen cycle than the Nat5, which is a slightly odd thing, but it is still the case. So I'm going to take it through at the Nat4 level, which is more detail, but still is worth you seeing. Okay, so the forms of nitrogen which you have. So this one we should know, amino acids. You know it in terms of it's needed to make proteins, and in particular we've talked about them a lot in terms of enzymes, which are proteins, so therefore they come from amino acids, and so goes on. So every single amino acid contains an amine group. That means that they have nitrogen in them. Okay, nitrogen gas is all around us. About, close to 80% of the air round about us is nitrogen. Problem is that we can't do much with it. I mean, we breathe it in. You would think that would be useful, but when we breathe it in, it just comes straight back out again because it's really unreactive. So we can't get it in to do something useful. Okay, so nitrite is a stable form of nitrogen that you get in the soil, but it's not one that we can use. But nitrate is. And so that's a really, really important one because nitrate in the soil is soluble and it can be taken up by plants in the roots. Okay. And then we also have another set of compounds called ammonium compounds, which you get when you break down amino acids. So overall, just an important, really important element for us. Okay. So we have several microorganisms involved in this. So we have some that are called nitrifying microbes that can convert ammonium through nitrates to nitrates. Okay. And now they're really, really useful because nitrates, remember, is the one the plants can actually take up. But then you also have some called denitrifying. And what they do is they take the nitrates and they break them totally down and release it back into nitrogen gas in the air, which is kind of a step back as far as we're concerned because it means that plants can't take them in. And then we have our decomposers, which are the ones that are doing the breakdown to get them to ammonia. And finally, we have some really important ones. You have bacteria called nitrogen fixing bacteria, and they're really special. They live in the roots of some plants, leguminous plants, and they can actually take nitrogen straight from the air into the plant. So they skip the need for the nitrifying ones to convert it to nitrates to go into the plant. Okay. So in the nitrogen cycle, obviously a lot of words beginning with N. So nitrification is where we are making that really useful compound nitrate, and the process of getting to nitrate is nitrification, wherever you came from, whether it's ammonium, nitrogen gas right at the beginning, or nitrite. Okay, and these would be nitrifying bacteria in the soil that will do this. So our ammonium, remember as well, can also come from amino acids. So as they break down by decomposers to ammonium, that then feeds into our nitrifying bacteria to make nitrates. On the flip side, we've got denitrification. So our nitrites and nitrates could also just be changed back into nitrogen gas, and that will be by denitrifying bacteria. Right, if we put this all together, now this is going to look quite complicated once it's all done, but it's okay if you're working it through as we go. Right, so starting off, if we have our nitrogen gas and we need it as nitrate, so the useful one, we want to convert it via ammonium nitrite to nitrate. Okay, this is going to be nitrifying bacteria are going to do this. We can also send it straight back up again using denitrifying bacteria. Okay, the nitrate is useful because plants can take that up in the soil and make it into amino acids. So we've now got protein in plants. Now plants can also, if they've got a special type of bacteria, this is your nitrogen fixing bacteria, they could take it straight down from nitrogen in the air. Okay, so in plants, we've now got to kind of complete another part of the cycle. Plants can be eaten by animals, so that means the amino acids are in the animals now, and both the plants and the animals produce waste, they die, they get broken down, and so they get changed into ammonium, and then the ammonium goes to nitrites, nitrates. So we've got kind of cycles within cycles in this one. So let's have a look at another version of that. Okay, so here we've got kind of soil down the bottom and sky up the top. Okay, here's our nitrogen, kind of useless to us at the moment. So we have nitrogen fixing bacteria. They can come in, and so there'll be only certain plants that could do that, leguminous plants, but they can actually get it straight down into the soil. Okay, that also in the soil we've got ammonia to our nitrites and our nitrates. That can go into just any old plant. Okay, they can just take it in through the roots, and the leguminous ones could as well, but they don't have to. Right, so we've now got plant protein. That can go to animal protein. Okay, the animals and plants all produce waste. Okay, and all of that gets fed down into ammonium compounds again. And that cycles round. But our little things at the side, we also have denitrifying bacteria that can flip it back up into nitrogen in the air. Okay, so this is your basic nitrogen cycle. So another couple of things to add to this. So we start with our atmospheric, fine. What you also can have is lightning strikes. Now lightning strikes, because you're putting a huge amount of energy through a mixture of nitrogen and oxygen. Nitrogen is not very reactive, but under those conditions, something will happen. And you get nitrogen oxides which dissolve in water to make a form of acid rain, and you get some nitrites into the soil. So they can just go through your normal cycle. I've got nitrates now, so they can go to plants. And once I've got plants, we've got animals can feed on them. So we've now got animal protein. And yet again, we look at this as being death and waste and decomposers. And your denitrifying bacteria can take the nitrates out. So we've got a kind of side cycle part of this, all connecting into the cycle. And then we've got something that is totally created by us. Taking nitrogen and also hydrogen, we can create fertilizers. Okay, fertilizers obviously at this point are unnatural fertilizers, they're man-made, and these fertilizers are putting on basically useful nitrogen for the plant, so that's nitrates. Then the nitrates go up into the plant, which can then be eaten by an animal, etc, etc. And then it just goes around our normal set of things. So important key points here. Your nitrates are soluble. That's really essential, because if you don't make them soluble, the plant can't take them up with water through the roots. Your nitrate you get from breaking down organic materials or from adding in fertilizers, and it would be nice if you knew your kind of ammonium nitrate, but you don't need to know that unless you're doing the NAT4 content as well. Okay, you take the nitrates in through the plant roots, and then the nitrogen and the nitrates you use to make amino acids. Amino acids can then be put together to make into proteins. Once you've got proteins in plants, animals can take that in by eating it, break it down, they've then got the amino acids that they can make into their proteins. And that's pretty much it. Waste goes back in and gets recycled. Not the easiest thing, work through it a couple of times.